Welcome to G Fun Facts Online, the show that peels back the layers of the world around us. In the feverish months before any big election, it feels like we're all addicted to one thing: political polls. They splash across our news feeds and TV screens, telling us who's up, who's down, and who's got the momentum. They're the daily scorecard of democracy, fueling either our hopes or our anxieties. And then, election night comes. And sometimes, the results are so different from the polls that headlines scream about epic failures and polling misses, leaving all of us wondering, is polling just a guessing game? Is it more like alchemy than actual science? The answer is a definitive no. The truth is, political polling is built on a foundation of rigorous mathematics. The uncertainty, the potential for big mistakes, it isn't a sign that the science is broken. It's an inherent part of the process, and we can understand it through two critical ideas: the margin of error and the hidden danger of sampling bias. Today, we're going to pop the hood on the statistical engine that drives political polling. We'll demystify the numbers, figure out why polls work, why they sometimes fail spectacularly, and how you can become a critical, informed analyst instead of just a passive consumer of the data. So let's get started. First things first, why do we even do polls? At its core, a political poll is an exercise in what's called inferential statistics. It would be impossible to ask every single eligible voter in a country who they're voting for. That process is called a census, and the time, cost, and logistics are just astronomical for a single survey. So pollsters do the next best thing. They select a smaller group, called a sample, with the goal that this small group will accurately represent the entire population of voters. Think of it like making a big pot of soup. You don't need to eat the entire pot to know if it's seasoned correctly. You just need to take one well-stirred spoonful. In polling, that spoonful is the sample, and the well-stirred part is crucial. For this to work, the sample has to be chosen randomly. A random sample is one where every single person in the population has an equal chance of being selected. This is the cornerstone of scientific polling, because it helps ensure the sample isn't accidentally skewed toward one type of person or political viewpoint. But before they can even start, pollsters have to define their target population. Are they interested in all adults, only registered voters, or the group that's hardest to pin down, the likely voters? The choice of who you're targeting is one of the first and most important decisions a pollster makes, because each group will give you different results. Now let's talk about the most famous and most misunderstood number in all of polling: the margin of error. When you see a poll, it's almost always followed by something like plus or minus 3 percentage points. That little phrase is the margin of error. What it really is an admission of uncertainty. It's the pollster telling you, hey, because we only talk to a sample of people, not everyone, our result probably isn't perfect, but we're pretty sure the real answer is close. The margin of error gives us a range where the true value for the entire population is likely to be. Most polls report their margin of error at a 95% confidence level. This is a key detail. It means that if you were to conduct the exact same poll 100 times, with 100 different random samples, you would expect the result to be within that margin of error of the true population value, 95 out of those 100 times. Let's make that real. A poll shows candidate A has 48% of the vote, with a margin of error of plus or minus 3 points. This does not mean candidate A's support is exactly 48%. It means we are 95% confident that their true level of support among all voters is somewhere between 45% and 51%. It's a range of possibilities, not a single, concrete number. So what drives this number? It's mostly determined by one thing: the sample size. The relationship is simple. The more people you talk to, the smaller your margin of error. The more data you have, the more precise your estimate becomes. But there are diminishing returns. The jump in accuracy you get by going from a sample of 200 people to 1,000 is massive. But the jump you get from 1,000 to 2,000 is much, much smaller. This is why most national polls you see use samples of around 1,000 to 1,500 people. It strikes a good balance between getting a decent level of accuracy and the costs of conducting the poll. Unfortunately, the media and the public often get the margin of error completely wrong, and it creates a ton of false drama. This leads to what I call the horse race fallacy. A news report will breathlessly declare that one candidate is leading when they're ahead by just 1 or 2 points, even if that's well within the margin of error. Let's go back to our example. Candidate A is at 48%, candidate B is at 46%, and the margin of error is plus or minus 3%. This is not a lead. It is a statistical dead heat, a statistical tie. Why? Because candidate A's true support could be as low as 45%, and candidate B's could be as high as 49%. It's entirely possible that candidate B is actually ahead. And here's a pro tip, a fun fact that will make you the smartest person in the room when talking about polls. When you're comparing 2 candidates, the margin of error on the time-so gap between them is roughly double the margin of error for each individual. So in our example, the 2-point gap has a margin of error of about plus or minus 6 points. For a lead to be statistically significant and real, the candidate would need to be ahead by more than that doubled margin. Another huge misconception is that the margin of error covers all possible problems with a poll. It doesn't. It only accounts for one thing: random sampling error. The random chance that your sample wasn't a perfect reflection of the whole population. It tells you nothing about the other, more sinister kind of error, which we'll get to in a minute. And finally, remember this: the margin of error applies to the whole sample. If a report starts talking about a specific subgroup, like voters aged 18 to 29, that subgroup is much smaller. If the total poll had 1,000 people, maybe only 150 of them were in that age group. For that small slice, the margin of error isn't plus or minus 3%. It might be closer to plus or minus 8 points, making any conclusions about that group much less certain. So, if the margin of error is the problem that pollsters openly admit to, let's talk about the hidden menace, the thing that can systematically destroy a poll's accuracy from the inside out: sampling bias. While random error can go in either direction, bias pushes the results in one, consistent, wrong direction. It happens when the sample you collect isn't truly representative of the population you're trying to measure. The most famous cautionary tale in the history of polling is the 1936 Literary Digest poll. It was a massive survey that polled millions of people, so its random margin of error was almost zero. It confidently predicted a landslide victory for the Republican candidate Alf Landon over the incumbent Franklin D. Roosevelt. But Roosevelt won in one of the biggest landslides in American history. What happened? The poll was incredibly precise, but precisely wrong. Its sampling bias was enormous. They drew their sample from 2 sources: telephone directories and car registration lists. Back in 1936, during the Great Depression, owning a phone or a car was a luxury. By only polling people from these lists, they systematically excluded lower-income voters, who were overwhelmingly supporting Roosevelt. The poll wasn't a reflection of America. It was a reflection of wealthy America. This is sampling bias, and it's a poll killer. Modern pollsters face this challenge every single day. One type is selection bias. In the past, polls that only used landlines systematically missed younger, more mobile voters who only had cell phones. Today, online-only polls might miss elderly or rural voters who don't have reliable internet access. Then there's what might be the biggest challenge in polling today: non-response bias. This happens when certain types of people are just less likely to answer a pollster's call, and their refusal is related to how they vote. For instance, what if supporters of one candidate are more distrustful of institutions like the media and polling companies? They won't answer the phone, and they will be systematically underrepresented in the poll, skewing the final result. In the 1990s, poll response rates were over 36%. Today, they are often in the single digits. This dramatically increases the risk that the tiny number of people who do respond aren't representative of everyone else. And of course, there's voluntary response bias. These are the unscientific polls you see on websites or TV shows, where they say, "Call in now to tell us who you support." The people who participate aren't random. They choose to participate because they are passionate and have strong opinions. These polls are pure entertainment. They have zero scientific value. So you might be thinking that polling is a hopeless endeavor, but professional pollsters are deeply aware of these problems, and they have a statistical toolkit they use to try and correct for them. The main tool is called weighting. After they collect all their data, pollsters compare the demographics of their sample, the percentage of men, women, different age groups, races, education levels, to known data about the actual population from sources like the US Census. If their sample ends up with, say, only 10% of voters under 30, but they know that group makes up 15% of the total population, they give the answers from those young people a little more weight in the final calculation. They essentially turn up the volume on underrepresented groups and turn down the volume on overrepresented groups until the sample's demographics mathematically mirror the population. Weighting is essential, but it's not a magic bullet. If you have very few people from a key group in your sample, weighting their answers heavily means you're amplifying the voices of just a handful of individuals, which can make the results very volatile. Another key tool is the likely voter model. Simply polling all adults isn't great for predicting an election, because not everyone votes. So pollsters have to predict who will actually show up. They develop screens by asking questions about a person's past voting history, their enthusiasm for the election, and their stated intention to vote. These models are part art and part science, and they're often a polling firm's secret sauce. A lot of the difference you see between polls from different organizations comes down to how they model who is a likely voter. This brings us to the real world, and what happens when all these mathematical complexities collide with reality. Let's look at the famous polling miss of 2016. In the race between Donald Trump and Hillary Clinton, the national polls were actually pretty close to the final popular vote result. The real failure was at the state level, particularly in key blue wall states like Wisconsin, Michigan, and Pennsylvania, where polls significantly underestimated Trump's support. The postmortems revealed two main culprits, both tied directly to what we've been talking about. First, some state polls didn't adequately weight their samples by education level. They underrepresented a key demographic, non-college educated voters, who broke heavily for Trump in the end. This was a classic bias issue. Second, a very large number of voters made their final decision in the last week of the election, and they disproportionately chose Trump. Many likely voter models, which are often built on past behavior, failed to capture this sudden late-breaking shift. These weren't just random errors. They were systematic biases that all pointed in the same direction across several key states, and they compounded to create a completely misleading picture of who would win the Electoral College. Given all these challenges, it's easy to get cynical. But polls, when you interpret them correctly, are still an incredibly valuable tool. You just have to approach them with a healthy dose of skepticism and a critical eye. So here is your practical 6-step guide to being a smart consumer of political polls. 1. Look at poll averages. Never get fixated on a single poll. A single poll can be an outlier. Look at the averages from reputable sources. This smooths out the random errors and quirks of individual polls and gives you a much more stable picture of the race. 2. Respect the margin of error. If a candidate's lead is smaller than the margin of error, the race is a statistical tie. Full stop. And remember our pro tip. For a lead to be truly meaningful, it needs to be bigger than twice the reported margin of error. 3. Check who was polled. Was it all adults, registered voters? or likely voters. Likely voter polls are usually more predictive closer to an election, but their accuracy depends entirely on the quality of that secret sauce voter screen. 4. Look for transparency. Good polling organizations are open about their methods. They will tell you the sample size, the margin of error, the dates of the poll, and how they weighted the data. If a poll hides this information, be very skeptical. 5. Focus on the trends. A single poll is just a snapshot in time. It's far more useful to look at how the numbers are trending across multiple polls over several weeks. This can reveal genuine shifts in public opinion, separating real movement from statistical noise. And finally, number 6. Always acknowledge the unseen bias. Remember that the biggest potential source of error, bias from people not responding, or from a flawed likely voter model, is not included in the margin of error. This is the great unknown in every poll, and it requires a bit of humility from everyone. In the end, the mathematics of political polling doesn't give us a crystal ball. It gives us a framework for understanding and quantifying uncertainty. The margin of error tells us how much random chance affects the result. The concept of sampling bias reminds us of the huge systemic challenges that can steer a poll wrong. By understanding both, you can move beyond the dramatic horse race headlines and engage with polling data the way it's meant to be used, as an imperfect but indispensable guide to the constantly shifting landscape of public opinion. Thanks for tuning in to Fun Facts Online.